Let's imagine that a new business requirement comes in for our application. The I Love Coffee product team wants users to have the ability to recommend different coffees, and whenever that occurs, we need to add a new event to the database that can be used later for data analytics purposes. To pull this off, we're going to need two things here. We have to provide a new endpoint that allows users to recommend coffees, and we're going to need to store the event after that previous call finishes. In order for this whole process to succeed, we need both operations to be successful. Otherwise, we might have inconsistencies in our database. This is where transactions come in. A database transaction symbolizes a unit of work performed within a database management system. Transactions are a reliable way to accomplish multiple tasks independent of other transactions. There are many different strategies to handle TypeORM transactions, but we recommend using the Query Runner class because it gives us full control over the transaction. Note that there are other complex and advanced techniques to achieve this, which leverage Nest scope providers and interceptors to automatically wrap every write query in the transaction. But we'll be covering those techniques in upcoming advanced Nest.js courses in the future. For now, let's keep it simple so we can conceptually understand everything first. Before we get started, let's create this new event entity that we'll use to signify events that occur in our application. Let's create this new entity with the CLI and put it in an events folder. In a real-world application, we'd want to create and wrap this entire domain in a Nest module so that everything pertaining to events, such as services, controllers, etc., are isolated. But for now, we'll skip that as we don't need it at the moment. Just a reminder that we've passed the noSpec flag here again, so that the CLI doesn't generate a test file as we don't need them for entities. Now let's open up our newly generated file and define some columns we need. Just an important reminder again, let's make sure that the name of our class is event without the entity suffix, as we don't want the word entity in our database table name. For our event entity, let's keep it simple and add a few basic columns: ID, type, name, and payload. Payload will be our generic column where we can store events payloads. There's nothing new here that we haven't already seen and used for most of the decorators in all of our lessons so far. Alright, so let's continue. Before we're able to use this entity, we have to add event to the TypeORM for feature entities array in our coffees module. Next, let's make sure we add this new recommendations property we talked about to our coffee entity. In our coffee entity, let's add an additional column, calling it recommendations. Let's set the default value to 0 and make it of type number. Perfect. Now that we have our coffee and event entities all set up, let's get back to our coffee service and put everything together. In order to create transactions, we're going to use the connection object from TypeORM. Let's inject connection into our coffee service constructor the traditional way without any decorators, as they're not needed for it. Let's just pass in private read-only connection : connection. Great. Now let's use this connection object to create our first transaction. Let's get started by creating a new async method in our service and call it recommend coffee with one parameter, a coffee instance. Inside our method, we can see we're first creating a new query runner, then establishing a new connection to the database with this query runner. Once we have a connection established, we can start the transaction process. We want to wrap our entire transaction code in a try-catch finally, just to make sure if anything goes wrong, our catch statement can roll back the entire transaction. Remember that we said in order for this to succeed, both operations have to be successful. Transactions give us the ability to roll back and undo anything that happened in case something goes wrong. Inside our try statement, we can see we're increasing the recommendations property on our coffee and creating a new recommend coffee event. Then we're using the query runner's entity manager to save both coffee and event entities. And we could see in our catch statement here, if anything goes wrong saving either entity, we're catching the error to prevent inconsistencies in our database by rolling back the entire transaction. Lastly, the finally statement here is used to make sure we release or close the query runner once everything is finished. And that's it. Just like that, we can create transaction statements that can help us achieve multiple actions to our database, ensuring they only happen if everything is successful.